All right, so we just did this example where we found various points along an interaction curve, and now we can plot them. Maybe should have done that in the last one, but we're gonna do it now. If we go to, let's start at the beginning. Our axial capacity, PO, 1323.2. So we're gonna plot that 1323.2. Let's see, this is going to be my moment in kip feet. And this is going to be my axial load in kips. So, axial capacity, what moment does it have? 0. What, see, I'm gonna, what did I do here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Put 1,000, 2,000, 3,000, and what's that? Wait, 4,000. I was about to put 3,500 because I'm an idiot. Okay, and then 500 kips, and 1, 2, 3, 4, 5, 1,000 kips. So you can probably gather all your data, maybe summarize it. But I'm going to look at my axial capacity. Axial capacity was, let's see, we're going to draw it in black. Axial capacity was 0 for your moment because it's pure axial, and 1,323 for your axial, so what, 1,100, 1,200, 1,300 right here. 0 kip feet and 1,323 kips. That is P naught. Okay. Our next one, we're going to go back. Let's see. What do we do? The onset of cracking. At the onset of cracking, our nominal capacities were 851 kips and 221 kip feet. So 221 kip feet and 851 221 kip feet. Let's see. It's 200. Oh, there. The bottom is not in the thousands, it's in the hundreds. Please forgive me. I can't read my own writing. 100, 200, 300, 400. My little K's looked like zeros. I don't know why. Okay. So 221 and 221 kip feet. So let's see. 221 kip feet and 851. That's 800, 851. Is that right? Oops, black. 221 kip feet, and 851. And 851 kips. This is my onset of cracking. Over to the side. I want you to put PN and MN is going to be represented in black. So this is my axial compression capacity. This is my onset of cracking. Now, let's see, what happened, what did we do after onset of cracking? We did balanced failure on the next page, PN of 356 kips, and an MN of 355 kip feet. So 355, see, about right there, and about right here, right, something like that. 355 kip feet, and I think I put 356 kips. This is a balanced failure. Onset of cracking is when we have beginning to crack right at the beginning of crack on your tension side. So your strain and your tensile reinforcement is 0. Balanced failure is when your concrete and your concrete reaches ECU. It's onset of cracking and compression, and then you just reach yield on your tension side. Our other, let's see, about next is tension controlled. Axial capacity of 153 kips and 297 kip feet. So 297 kip feet, 153 kips, something like that. 297 kip feet, 153 kips. And this is tension controlled. That means I've gone beyond yield in my tensile reinforcement, and my extreme tensile reinforcement, my ET, is the yield plus 0.003, so that I can use that phi of 0.9. Of course, so far we haven't added phi in, right? And our final one is we just did moment only. So no axial load, our PN is 0. We got our moment to be 235 kip feet. 235. Let's see, something right here. 235 kip feet, 0 kips. And it's moment only, bent flexure only, no axial capacity whatsoever. No axial, capacity. Basically what you've been designing so far. And then we get to draw a straight line between all of these little points. Let's see if I can do that. So that is my interaction diagram, but only using the nominal capacities, which is a bit of a misnomer up at the axial compression capacity, but we'll talk about that in a minute. Okay, so this is our interaction diagram so far of only the nominal capacities. So phi, how do we add in phi? Well, let's see. We'll go to our handy dandy ACI 318. Our phi factors on page 391. What do they say? It says for moment, looking at the very first table, strength reduction factors for moment, axial force, or combined moment axial force is going to be 0.65 to 0.9 in accordance with 21.2.2. So we get to use the same phi factor equations that we just have been using for, or that we've already been using for moment. Because we're talking about a column that has an axial force or combined moment and axial force. So 21.2.2 on kind of the next page. It depends on our, right, here it is, moment, axial, or combined. Depends on the tensile strain in our extreme tensile fibers. And it depends on the type of reinforcement. Whereas typically in our beams, we're unlikely to have spirals. Now it comes into play because we might have spirals in a column. We're more likely to. But this, let's see, this one, let's go back to here. Right? Same, I don't know what I want to write, same phi factors for moment only. Right, it's the ones we just did. So they depend on the strain in your extreme tensile reinforcement. If our strain is less than yield, we have compression controlled. We haven't yielded at all. Let's see. Spirals versus ties. This is all in that table. But if we have spirals, our phi is 0.75. And if we have ties, our phi is 0.65. On the other hand, if our strain or extreme tensile reinforcement is greater than or equal to the yield strain plus 0.003, we are now tension controlled. And we get to use a fee of 0.9 regardless of if we have spirals or ties. What do we have if we don't have either of those situations? If we're between yield and yield plus 0.03, we're in transition. And then you get to use the lovely interpolation equations. Phi equals 0.75 plus 0.15 0.003, or the same comparable equation with the ties, but you start at 0.65 and you increase by 0.25. Again, this is all on in your manual on page 393. Right. Which you for sure have already had marked, but I'll just remind you. So now we have our phi factor, but there is one more thing that they want you to think of. Let's see. But there's actually a PN max. They don't. Research has shown you shouldn't go all the way to just phi times the axial compression capacity. So it's on page 8. It's in the next chapter, chapter 22. So this is something you're probably going to want to, there's PN max, there it is. Let's see. Chapter 22 is it's still about your strength. Now you're talking about your section strength. We used the flexural part already, where we had our Whitney stress block. All right, A equals beta 1 times C. We just used that again. There's our beta 1s. That's our flexural strength and how to calculate it. Now our axial strength, 22.4. This is on page 397. There's a maximum axial strength. That bigger. There's a maximum axial strength. We calculated this PO value already. Now, if we have ties, we're in non-pre-stressed, right? Not looking at pre-stressed or deep foundations. If we have ties, we decrease that PO that we calculated by 20%. If we have spirals, we get to decrease it by only 15%. right? 0.8 or 0.85. And then this is your PN max. So really our PN max, we needed to chop off that, our interaction diagram. I'll show you what we're talking about. But we don't want to use the PO that we calculated, is what we're saying. VPN max. Let's see, ACI, that's an I. 318, let's see, 22.4. It's page, it's on the other side from the beta 1, so it's page 400. My nominal axial capacity is limited to this PN max. And we're talking about non-pre-stressed. If we have ties, 0.8 PO, spirals, 0.85 PO, where PO was that 0.85 F prime C times your area of concrete, AG minus AST, plus your yielding of your steel. So ties is going to be limited to 80% of this value. Spirals are going to be limited to 85% of this value. And then you add on the phi factor. This does not take the place. I don't want to say that. Let's see, phi factor still needs to be included. So first let's calculate our fees and then we'll do this little cap. Probably should have done those first. So let's see. We go to our axial. What phi factor? I'm going to go all the way back. We're going to just start adding in phi factors. What should our phi factor be for our axial capacity compression? Is it compression controlled, tension controlled, or in transition? You should all be screaming compression controlled because it's compression. Phi PO. We're going to cap it in a second, but so let's see. Compression controlled. So phi is equal to, these are ties, so 0.65. So phi PO 0.65 times 1323 kips. $860 kips. So I'm going to go to my interaction diagram. I'm going to draw data point, including fee. That was 860 kips. 6, 7, 8, 60, somewhere around here. 0 fee PO, right? 0, 8, 60. Up to 0 kip feet. Let me just. And 860 kips. This is fee PO. Okay, go back. Let's see our onset of cracking. Onset of cracking. What is the strain in my extreme tensile reinforcement? Right here. What is the strain? It's 0. So ET equals 0. Therefore, compression controlled. Still have ties. We haven't changed anything. So my phi is 0.65. So my phi PN 0.65, 851 kips. $553 kips, and my phi MN 221 kip feet. 144. Okay, so now I can take those new values. Let's see, 144 kip feet and 553 kips. 144 and 553, so that's about here. Something like that. 144 kip feet, 553 kips. Okay, let's make a little thing off to the side. This is for phi PN and phi MN. I shouldn't make that in red now that I'm thinking about it. I'm gonna change colors. Just a sec. $144, 553. Right. And 0 and 860 over here. Oops, that's kips. And that, I just want you to remember, is phi PO. I should make that green. My axial capacity comes down from 1323 to 860. My onset of cracking from 221 kip feet to 144 and 851 kip to 553 kip. Let's see. Next one is balanced. So let's see. What's my strain in my extreme tensile fibers? It's EY. Now, if there was several layers of reinforcement, then ET would not be equal to EY. It might be a little bit more. But since there's only one layer, ET is equal to EY. Because it's equal to the strain in the extreme tensile, and there's only one layer. So let's see. That means we're still at compression controlled. We're right on the cusp between compression controlled and transition, right? So phi is still equal to 0.65. So phi PN is equal to 0.65. Oh gosh, I should have done this on the next one. Because this isn't where the stuff is. But you can see my strain right here is equal to EY. So let's see. ET is equal to EY. Compression controlled. Phi 0.65. So my phi PN is equal to 0.65 times that 356 kips. Should give you 231 kips. My phi MN 0.65 times 355 kips, which should give you 231 kips. Feet. Kip feet for my MN. So 231, 231, that's easy enough to remember. Two 231. Oh yeah, I'm in blue. 231, 5, 2, something right here, right? Tension controlled is our next one, and I think that kind of answers the question in itself. ET is equal to EY plus 0.003. By definition, this is tension controlled. ET is equal to EY plus 0.003. Tension controlled. And therefore our phi is equal to 0.9. So, and that's phi for both the axial and the moment capacity. This isn't like in Steel, where you might have a different fee for an axial or for a moment. In concrete, it's the same fee. It depends on your strain. So fee PN is equal to 0.9 times 153 kips. $138 kips. Fee MN is equal to 0.9 times 297 kip feet. 267 kip feet. So we can go put those in there. I was at what, 100, 267 and 138. So 267, 6, 7, and 138. So it's somewhere like, oops, I don't want to add. 4067, somewhere like right here. Yeah, 267 kip feet and 138 kips. Finally, our moment only. Let's see. How's our tension controlled? Here's our moment only. We did this little equation. This one, we don't care. We should, just to double check, let's find ET. It should be greater than, but let's see. ET is equal to C over ECU. Wait. Yeah. ECU over C times D minus C. D1, whatever it is. So 0.003 times, let's see, C, 3.45, I decided. 13.5 inches minus 3.45. I iterated to find that, if you don't remember. 3.45 inches. 0.003 times minus 3.45. 0.0087, which is greater than EY plus 0.003, which is about, because this is 60 KSI, 0.005. So it's tension controlled, which is what you would expect. A C, right? The C here is 3.45 inches. That's my depth to my neutral axis. In tension control, it was 5 inches. If you make your C shorter, you increase your strain in your extreme tensile steel. So since tension controlled by definition was the tension controlled thing with a C of 5 was by definition tension controlled, then if you shorten the C to 3.45 inches, you're going to increase that, what's it called? You're going to increase how much you've strained your tensile steel. So, retention controlled. Probably didn't need to calculate it, but it's good to double check. Like, we really shouldn't have had to calculate it, but for illustrative purposes, it's always nice. So let's see. Phi PN is equal to phi times 0 because we're moment only. So it's 0. And phi MN, well, I should have put 0.9. I mean, 0.9 times 0 is still 0. Anything times 0 is still 0. 0.9 times 235 kip feet. $212 kip feet. Make sure you guys got that all written down. I know I just went really fast. So our final is 0 and 200 right here. Oops. 212 kip feet and 0 kips. And you get to draw another. Right, so this is this is your interaction diagram accounting for phi. You'll notice some of them decreased by a lot, some of them didn't because, right, 0.65 versus 0.9 for my phi factor is going to change what it looks like. It's going to be more dramatic. So my last thing, my PN max, I have to limit it to 0.8 times PO because I have a tied thing. So this isn't really, not really valid. Maximum compression. Limited to PN max. And then phi PN max. To PN max nominal and phi PN max design. That says design. So let's see. PN max, because this is tied, is equal to 0.8 times PO. So that's 0.8 1323. All right, I already calculated the PO. It's right up there. So that is 1058 kips. And then fee PN max. I'm still just compression controlled. My fee is still the 0.65. There's no way, right? I'm literally in only axial compression. So 0.65 times PN max. So 0.65 times 1058 kips. Should give you 688 kips. So how do I do that? Let's see, 1058 and then 688, right? So 1058, 1058. What I'm gonna do is I'm gonna not do that. I'm gonna do this. See, 1058. Right here. In reality, I'm cutting it off right there. I'm gonna put this is PN max. And then, and I don't know where it hits in the interaction curve. I mean, I could interpolate and find it, but these are used for actual design. So we're building an interaction diagram to show you guys how to build an interaction diagram, but then for actual design, we're going to use previously built interaction diagrams. So then fee PN max is, what was it, 688? Like there. So this axial capacity, I guess I should have said that. That means even if, according to your interaction diagram, you could have an axial capacity of 860 kips, or if you're out like here, you know, or I don't know where you're at. It's like, if you're out here with a fee PN of 700 kips and a moment of 20 kip feet, your maximum axial capacity is limited to 688 kips. So our actual design interaction diagram is going to take that into account. You can still have up to, I don't know where this hits, You can still have up to, I don't know, 85 kip feet, but no matter what, you can only have 688 kips as your axial load. If you need more than that, you're going to have to change your design. So I'm just going to draw a little red kind of along all of this. Trying to draw it like right. It's on top of it is really. This is your design envelope, basically. Everywhere else it's fine. It's just your axial capacity is limited to phi PN max, is what that's saying. Axial capacity limited to phi PN max. Basically, you're just chopping it off. So as long as your loads are anywhere in this yellow shade, your designed beam will work. Okay, loading. Factored, right? As long as your applied loads, factored applied, loading, okay. As long as your factored applied loading is underneath the little red interaction diagram, it's anywhere in this yellow, then you're fine. It's just that VPN that chops it off, right? We calculated, oopsies. We calculated our nominal capacities, and we have to limit our axial nominal capacity to that PN max, even which is based off PO. And then we applied our phi factors, which depends on your strain and your extreme tensile reinforcement, so just the exact same as moment, and you draw it. So one other thing to mention, let's see, our phi factors. At the balanced failure, gonna draw a line from the center to the balanced failure phi PNMM. That is the wrong one. No, it's not. Yes, no, it's not. Okay. That 231 is our phi PN, phi MN of balanced failure. And then I'm going to draw another line from the 0 to the tension controlled. For my balanced failure, onset of cracking, and axial capacity for my balanced failure, onset of cracking, and my axial capacity. What was my phi factor? .65, because all of them were compression controlled. Oh, jeez. So anything above, maybe I should have made it a purple line. I don't know. Is it too late now? Gonna make it a purple line because it's fun. It's not even that obvious, but anything above that purple line is compression controlled. Where I had a phi of 0.65 because I have ties in this design. What's a color I haven't used? Is there a pink somewhere? Come on, pink. A teal? This is a terrible color. If you're red-green colorblind, you're screwed. Whereas my tension controlled, okay, so if you're above that purple line, you're compression controlled. If you look at, I just drew a line from, which is a terrible color, can barely see it. I just drew a line from, should pick a different color. I'm gonna draw this green color. Kind of a teal. I just drew that line from 0 to the tension controlled. You know, tension controlled and moment both had a phi of 0.9. They were both tension controlled. Phi of 0.9. So if your loading is below that teal line, you're in a tension controlled section. And I've run out of colors. I'll just go back to black. If you're in the middle, you're in transition. If you're between that purple and teal line, you're in transition. If you're colorblind, I'm very sorry. Maybe I should have made that like a highlight, that yellow. Oh well, c'est la vie. Too late now. Yeah. So you'll notice the biggest chunk is compression controlled, which makes sense because we're talking about an interaction diagram for a column. Very unlikely you will have a tension controlled column, but you could. It's not impossible, but you're gonna have, that means you have a lot of moment right? And not a lot of axial load on your column. So that is how we incorporate our phi factor and our axial capacity limitation, our PN max, to our interaction diagrams. Now you've drawn one, you've calculated it, you've drawn it, you've seen how the phi factors affect it, and our next step is to actually use previously made interaction diagrams to design a beam. Thank you. Okay, so I cleaned up the one that we just did a little bit, and just included, I took out all the values. I just wanted you to see the concepts, right? Here we have all of our compression control, and you see the difference from here to here is 0.65 all along it, whereas from here to here and for tension controlled and moment only it's 0.9. That's why we have this teal here. Compression controlled is in purple, mostly in compression controlled. I have my cap right there, so really everything in this light yellow is what's fine. If you're in this no man's land up here, it's not going to work because you have too high of an applied compressive load. So that is a cleaned up version of the one that we just did. And they're all going to generally have this shape. They might look slightly different. Sometimes like this little balanced failure moves in a little bit more, kind of have a little like bump out at the tension controlled. But they're all going to generally have this same shape. And you can solve for a bunch of different strain values all along and maybe round this out a bit. But that is how you do an interaction diagram. Okay? All right, now I'll really be finished.